For those of you who don't know Romain, you should know that before Romain became passionate about programming, he spent, I think it was 10 years, wasn't it, Romain, herding goats in the Himalayas. A warm welcome to Romain Podszewska.
Thank you, Francis, and welcome everyone. And so the topic of today, I just called it from desk to wall and back. This, I would say, summarizes really in a nutshell what I've been up to. My current company called Bluescape. We're a software company based in San Carlos, California. Even though these days I'm working remotely from Austin, Texas. And what essentially I'm doing at Bluescape is, or we're doing at Bluescape, is doing wall-sized user experiences and wall-sized application. By wall-sized, I mean our application runs on wall-sized touchscreens, which use both fingers and pen. And as part of that, we've spent the last 3-5 years really improving our product. But as I'll be presenting later on, we went from the desktop to the wall, but we are also now going from the wall back to the desktop by trying to provide some of our application features back in a desktop or laptop size application. So some of what I'm going to talk about today relates to this, but I'm also going to give you general tips and general information about, what the topic of this conference is, standard desktop applications. So for a lot of people working on desktop app, you're really stuck in a mouse versus keyboard usage and interface type of things. So sometimes it would be nice to be able to also figure out, hey, what if I had a touchscreen available, or what if I was able to have external devices, and how to make use of those in your existing application. So that's really the topic for today. It will be mainly centered around, for my demos and examples, it will mainly be around QWidget world and the standard desktop app world, but I'm also talking a little bit about the QML side. Right, so it'll be a little bit of both, but more on the QWidget side than the QML side. I will be presenting a little more insights about what I call mixed input applications, which is how to handle users that prefer using their mouse and keyboard versus how to handle users that would be either running on those 2-in-1 laptops that are becoming more popular, or even how to handle having your application running on one of those large screens like those that we use, which typically do not come with a mouse, but still have touch and pen support for them. Couple of tips and tricks. I'm only just quickly going through some examples of easy things you can do without having to re-architect and redesign your whole application. In fact, as we will find out, most applications run fairly well as is, and there's a few easy things you can do to give them a little kick to put it up a notch. And finally, as time allows, I will also presenting some of the changes around the input event handling coming in Qt 6, because there is quite some refactoring that's going on. I haven't checked the very latest, so maybe not all of it will go in time, but this should at least give you an idea of the major changes that should have been in already. All right, so let's get started. And I'm just going to give an introduction for those of you who are not familiar to the touch and pen input support in Qt, and mainly the different event types involved, how they differ from the mouse and touchpad support, and all these things. All right, so I'll start with the C++ side. In the QGUI and QWidget world, the multi-touch support is handled via the QTouch event class. The difference with the mouse event handling and the keyboard event handling for that matter is for those events, there is a single event handler. You can intercept them on the window at the window level or on a per widget level, but there is no touch start or touch update or touch end event handlers, virtual overrides. In the case of touch events, it's a single event. And instead, you rely on the type of the event to decide or to figure out what is currently going on. So for multi-touch, there's 4 involved event types. It's, let me put them out here. There's touch begin. So that's what happens when a first finger touches the screen. Then you have touch updates. Anytime there are updates with either 1 or 2 or any fingers that are supported. And finally, the touch end, which is what happens once the last finger has been released from the screen. So this is the sequence that would match the mouse press, mouse move, mouse release, except for multiple points. There's a 4th one which doesn't exist in the mouse world. It's touch cancel. So touch cancel is when let's say you're in the middle of doing a drag gesture and the operating system decides to interpret your gesture as, I don't know, you're trying to swipe desktops or the device goes missing or something else happens that the touch can never be completed. So this one really means revert what you were doing. Let's say if you had a press going on and then you receive that, you shouldn't consider that from being a click. You should instead just, cancel the touch press. So once you have these, because you only get 1 touch begin for the first point, and then when touch updates at any time there are 1 or more points, the touch events themselves contain a subtype called QTouch event touch point and are listed as an array of touch points in the event itself. And then for each touch point, you extract information. The most interesting ones I've pointed out here are, of course, its ID, which is usually a 0-based identifier that's monotonically increasing. So the first point will be 0, second point 1, and so on. You have then all the usual flags that you would find on all the standard input events. There's a position, screen position, global position. You also have the floating versus integer variants. So yeah, there's a bunch of them, but all the interesting things you would need. You can also get, by the way, things like keyboard modifiers and so on. So, but that's not really the focus here. The last one that's probably the more interesting one is that state one here. It can be one of these. So touch point press, touch point move, touch point stationary, and touch point release. So this is what you would get within a touch update. So when you would get the first touch point down, it will obviously be a touch point press. And that will also be the touch begin. When your point starts moving after that, so you will then get some touch point move updates. Then if you were to put down a second point, you would then get a second touch point press, well, a touch point press state for the second touch point. And the first one then still keeps either move or stationary if it hasn't moved since the last event, right? And finally, when any of the the fingers are released from the screen, you get a touch point release. And like I said earlier, when the last one gets released, that's when you also get the touch in. So there's plenty of examples in the Qt examples that show how this works. So that's all I want to present for now. And the usual way you would do that then is via either on the window or on the widget level. There's more subtleties that I'm going to present in the coming slides regarding how do you ensure that widgets receive touch events. What if you just want to interpret touch event as a mouse event and so on. So I'm going to get to that in a little while. The tablet, so the pen support is the similarly called QTablet event. So back when they introduced it, those pens were mostly considered those Wacom tablets that were like sitting next to your keyboard or your mouse. So that's where the terminology comes from. Even though nowadays on the device that I'm presenting to you from is Surface Book, Microsoft Surface Book, which has a built-in touchscreen and pen digitizer. So the pen digitizer, the pen events come through as tablet events, even though they're technically on the screen. It's basically like having your tablet built in the screen. So similar here to what you have for a mouse. You have a tablet press, tablet move, tablet release. And then these two extra little ones here, tablet enter proximity and leave proximity. So these are the equivalent of the hover support. So I can show you well, if you see on the screen right now, let me see, I show my cursor. No, wait 1 second. There we go. Here, you should be able to see my cursor here. So I'm actually using my pen here to move around the screen, but I'm not actually touching the screen. So just like on those tablets, the pen, interesting, if I touch the screen, I can make some scribbles with it. All right. So you see the little cursor follows me even when my pen is not touching. So that's the same principle that they have on those Wacom tablets. It detects the proximity of the pen above the surface, which gives you the equivalent of a mouse hover even. That's why Windows in this case can show the little pen crosshairs following my pen. All right. So that's what these two guys are for. There's also a set of properties on each of these events. We have the unique ID. So we'll see how there is no device associated with a tablet event, and that's kind of a shortcoming of the Qt 5 API. And that's one of the things that they are going to fix in Qt 6. But this unique ID is more or less a device ID, except that it's opaque, and it's Qt who assigns it based on a plugin that you're using or the QPA that you're using. It does not necessarily match the actual hardware device that you may have and that you may know. So keep that in mind. It's a unique ID, and it's also not necessarily unique across restarts and reboots. I think it's a unique for the duration of the application. And it's unique in case you would have more than one pen, which is also possible. These devices can support, some of the tablets can support 2, 3 pens at the same time. All right. And so even pen tips, if you had different pen tips for different types of strokes, each of them keeps its own unique ID for the duration, but then also loses that as you restart. Same other things, position, device here is not the touch device. Device actually represents, it's an enum in Qt tablet event. It just tells you if it's like a pen or a 4D mouse or some other brush. Yeah, it's an enum. It's not an actual physical device, right? And point and type here would give you if it's a cursor. For pens that have buttons that let you switch between drawing and erasing, it would give you the current modes. We'll have a demo later on where we show you that sort of stuff. All right, so you can see here the pointer type is one of these, pen, eraser, cursor. Quickly, on the QML side, there's actually 2 APIs. There's I was going to call it the legacy API, but I think it is not being deprecated in any way. It's just one API, and they have introduced a separate one, but you can still use that one. The multi-point touch area is the equivalent of a mouse area. It works the same. You anchor it against a parent item or any other item. You can specify how many points it should accept. So the idea here is that you can limit how many points are recognized under the user. And it's kind of a filter. So you can say, hey, I don't want this area to trigger until there's at least, in this case, anything from 1 to 2 points would be recognized. But you can say, I only want to start recognizing when there's 2 points minimum. So that's the point of these two. And then you have a bunch of handlers. You have untouch started, untouch updated, untouch ended. They map more or less to the C++ side that we have just seen. And you do have access to same thing, those touch points that were part of the QTouch event. They are wrapped in a touch point object here, which has similar properties. So this allows you essentially to map, to implement the C++ behavior or C++ handling in QML. Not that I would necessarily recommend it. I generally find that doing that sort of stuff is better done in C++ via custom components. That's usually what you have anyway, but it's there. I have used it occasionally when I wanted to do some filtering from, for example, when using web engine views, and I don't want the web engine to start interpreting my pinches as zooming the page and stuff. I would use a multi-point touch area to intercept those events and then just prevent them from going through to the web view itself. So starting with Qt 5.10, there is a new type of handlers. They call them pointer handlers. And those are kind of like higher level. They do some gesture interpretation for you, and they also have some built-in behavior. So for example, drag handler, that would be if it allows you, if it's put inside an item, it automatically updates and moves and pans the item around as you are touching it with 2 fingers, for example. You also have a pinch handler, which same behavior. You can automatically rotate, zoom, and pan your object around as you use a 2-finger pinch gesture. So if all you want to have is a draggable and pinchable and zoomable and rotatable object, you do like you do in this example here. Just put that object in here. You would not add that target. By default, it would use the parent as a target, and it just handles all of the events and the modification on the item for you. But you can also use them either to target another item, like I have in the drag handler example up there. So the handler is on one item, but what gestures you do on it applies to another item. Or you can also disable the target object, which is what I do at the bottom here. And by disabling it, you can just use the object properties to trigger whatever. Let's say you want to trigger a view, reload, or anything else that you want. And then you can use the properties such as scale or rotation or translation to trigger your other property bindings like we do here. So here in this case, if I were to do a pinch zoom on this object, I would just update the label of the object with the current properties of the pinch. All right, so I'm not going to go more into details for the QML side. There are, interestingly, some single point and other type of pointer handlers. It's not limited to multi-touch, but they have introduced a separate tap handler, which does a few more things that the mouse area doesn't do. They have a wheel handler, hover handler, and point handler. Yeah, the wheel handler and hover handler to some extent are useful. Point handler is like really in the documentation, they explain the use for it. It's mainly if you want to do some, filtering of touch events, but purely on the QML level. So that also, I'm not sure I would do it this way, but depending on your use case, that could be something you want to do. Okay, so now a few other things, flags, options, and things to know regarding how things work. Before I dive into that, actually, let me take a quick break and just do a quick recap. You're a desktop application developer. Traditionally, all your app, standard desktop app using mouse and keyboard. Okay, how does that, I guess at this point, the question you would have is, how does that relate to me? Does that mean I have to start adding touch event handlers everywhere for all my widgets and all my windows? What if, I just want, when the user taps the screen, I just want them to, as if the mouse was clicking. So the good news is, if you really want the basic mechanism, Qt does that for you by default. All right. And this is what we see here with these QGUI application flags and mostly the defaults. So there's 3 interesting ones. The first one, synthesize mouse for unhandled touch events, means any touch event that is not explicitly accepted and handled in an event handler or an event filter will be converted by Qt into a mouse event. So that's great news, because that means if you don't do anything to your app, which we're going to see a quick demo afterwards, Qt just allows you to use a single finger as a mouse cursor, right? The only thing you lose is you lose the hover, but that's fine. Same thing goes for pen. There's a separate flag here, synthesize mouse for unhandled tablet events, defaults to true as well, which means that as I'm dragging with my pen around here and I'm tapping things, without any custom event handling in my Qt application, Qt will just convert those automatically into mouse events. So you'll get mouse hover, mouse move, and then when you press and release, you'll get mouse clicks and everything like that. So if that's really all you need to do, there's nothing extra you need to do here, which is good news. There's a third one, less interesting, but I'm still mentioning it for the sake of being complete. Synthesize touch for unhandled mouse events. That one is defaults to true. But let's say if you have a touch centric and you really want to kind of funnel everything through touch events instead of mouse events, you can turn this on, and basically all the mouse events that are not explicitly handled in widgets will then be, or you custom, I would say in custom widgets, will be converted to touch. So not as common, but still good to be there. All right, so time for a quick break and a quick demo here. Let me just do a quick check-in. Everyone's still following? We're good. All right, let's not enter the vortex of screen capture recursion. All right, so I have a quick example here. Very basic. All right, it's in standard, app with a couple of, I have a list view on the right, I have a text view on the left, right? Text view, I can scroll with my wheel, all right? Or can select, I can do my right clicks and so on. And then my close button. So with nothing special going on, if I was to use the pen, let's see what happens if I'm now dragging over the pen. You can see that I do have the same hovering as if it was my mouse cursor. All right, I'm showing it's my pen here. Other hand, showing it's not me. Other hand is here. Don't have my hand on the mouse. And as I drag my pen, I can then select text and so on. Right, just like if it was a mouse cursor. I can also use the touchpad, by the way. So now my hand is on the touchpad, and as I drag with one finger, same behavior, selection, and as now I do a two-finger drag, notice how, this case, I think Windows is the one that automatically converts these into wheel events that are being sent to the app. All right. Now, as my pen was selecting, I can also use the pen here to click and to close my application. I'm going to do now the same example with my touchscreen, and here's the joke here. Over the weekend, my laptop has started misbehaving, and so my touchscreen is actually now creating a permanent touch, so which completely disables any other mouse cursor device. So you can maybe see that square on the right edge, on the left edge of the screen here. Yeah, there you go. That's the touchscreen misbehaving. So I'm still gonna try to show you the example. Wait, oh, I'm sorry. I actually have to disable the device. I swear I didn't make this up. It literally failed me over the weekend. I need to start the app first, because once that touch point goes in, I can't do anything else anymore. No more mouse cursor, nothing. That's the Murphy's Law for you. So starting, now my touchscreen is enabled again. I can still, though, even though I have one touch point stuck on that window, I can still interact with the other one. Oh, no, I can't. Look at that. I'm guessing it's really... Oh, okay. There we go. I can still if I put two fingers on it. Okay. All right. My two fingers now are properly converted. So in this case, Windows is converting my touches into wheel events. So that's actually a pretty good design. And I may have, there may be something going on in the sample here that disables the single touch. But if I were to do a single touch, it should do like with the pen, that I can select the text and I was able to do long press, it should also pop up the context menu. But for some reason here, the single presses are not being recognized. And I'm going to guess because of that stuck touch point on the other window. Alrighty. So the good news, to summarize, is by not doing anything, you already get some behavior for free. And I would say some, though, because it's not complete. As we saw here, it allows you to do scrolling, but it wouldn't support pinch zooming, or it wouldn't support custom behavior on, let's say, if you wanted to be able to do drag and drop and so on. So it's really just the basics, right? So there's still going to be some work that would need to be done if you want to augment a little bit on that. But at least that gets you going without much effort at all. So on the QWidget side, if you want individuals to accept touch events, there's a special flag you need to turn on for it. It's called accept touch events. Most built-in widgets, though, have that on by default. Like all the scroll area, I think, have it on by default, and that's how they will be able to do the scrolling and with the 2 fingers and so on. But if you do a custom widget, you may need it if you want to be able to, if you don't want to automatically convert to mouse events. That's the trick. I was going to show, I'm going to skip that part because with the touchscreen misbehaving. One thing I was going to show you is what happens if you were to turn off, on at least on Windows, what if I was turning this flag, synthesize mouse for unhandled touch events to false? If I was to turn this off, I would still get mouse events. Like as I touch with my finger, I would still see some mouse clicks and so on going on. The reason for that is Windows itself tries to convert touches into mouse events, and Qt by default will just forward these events back to the app. So really, if one of your goals is to completely disable any touch from happening in your app, let's say you really just want mouse and keyboard, you have to actually both turn off this application flag and either provide that option to the Windows QPA plugin during load, or an alternative, as we'll see in the demo source, is to detect such mouse events. Right? So I'm just going to show you quickly how this works. So to be able to use the QPA flag, there's you can pass it via the command line, but that's usually not super convenient. So one thing you can do is using a Qt.conf that is embedded in the app. So Qt.conf, for those of you who are familiar or not familiar with it, is that file that lets you specify where to load plugins, the different paths, and so on, like the prefix for where to find the Qt libraries and plugins and other options. And one of the sections that it has is the platform section. And on Windows, you can actually specify these 2 lines: platform, Windows argument no mouse from touch. And if you have a QRC file, which you normally have in any app anyway, by putting this, saving this file under the /CLUD/etc and compiling it into your application, of course, it passes these arguments. So that's built in when the app starts. You don't have to have anything on the command line or no environment variables, nothing. So that's actually pretty nice. So this is why I was not saying the touch earlier, because I had this thing set in there. Now I remember. Right. I think that's about it. On Linux, you do not have a similar option with XCB, at least. But on Linux, what you can do is you can actually turn it off in your xorg.conf file, or you can also call a separate tool that basically allows you to disable the mouse cursor if X11 is giving grief for it. It's depending on your platform. I cannot really explain it because there are many cases. So it doesn't, some cases it's needed, some cases it's not. So, but just know that on Windows, it is an argument you can pass to the QPA. All right. Here's an interesting tidbit. QScroller is a class that was introduced to sort of match the flickable aspect on QML. So when QML has a built-in support for flicks and kinetic scrolling and all that stuff. But as you saw earlier, when you're on the Qt side, on the QWidget side, you do get the wheel events, but you don't get any of that kinetic scrolling. So the QScroller class was added for that purpose. It's generally a class you can use with a couple of static methods. So I'm showing you the main ones here. There's QScroller grab gesture. You specify any area that's a subclass of scroll area. And you can specify as a second argument, you can specify if it should be a mouse left click or right click or drag, I should say, or if you want it from touch gestures, right? And you can also programmatically tell it to do a kinetic scroll, to a specific point in your scroll area from where you are. And so the QScroller figures out how fast it has to scroll and how much it has to scroll. All right. Be careful though, as we're going to see a little later, grab gesture with the touch gesture arguments disables the single finger selection support, which is normally something you want to keep. It does not understand that it should only do kinetic scrolling for 2 fingers. It immediately intercepts your single finger and does scrolling with that, which disables the single finger selection support. So you should avoid it, but we'll see in the example that in the demo, we'll see that it's still useful. Let's say if you want to assign it to a middle mouse button. So we'll see a bit an example about that a bit later on. All right, let's do a quick interlude. I'm doing a quick time check here as well. All right, about halfway. That should be good. Mixed input applications. Here, I just want to give you the example of Bluescape. Bluescape is meant to be used as a native app, so on the large scale screens, but we also have a web browser client as well as a mobile client. So we really span, with the native app, we really focus on touch and pen enabled large devices. But when you're running on a web browser client, our main interface and the main interaction is mouse and or touchpads, right? Typically on laptops. And then on mobile, of course, we have strictly touch-based user interface. Mobile is kind of on the side because it's its own UX, but our app is very similar on our native app client and our web browser client. So we want our user experience to be the same. So even on the wall side, we have to do things the way that a user on a desktop will want it to use. Also because our goal is to have a native app that's also usable on the standard laptop, which is something we have in progress. So to give you a quick, I'm just going to give you here, hopefully you'll be able to see a quick idea of what I mean with all that. That's a short video. It moves quite fast, so I don't know if you'll be able to follow everything, but you will see what I want to show in this is how you have some parts where you see users on large walls and users on browsers and users on laptops and so on. So hopefully that'll give you a better idea of what I mean by mixed input.
The possibilities are pretty much endless in Bluescape.
It's about seeing the big picture all in one place.
right, so hopefully you were able to follow. I'm sorry, it kind of moves pretty fast. It was giving me a headache just looking at it. But hopefully you caught some of these patterns that we have where you can see it's very finger and pen intensive. Users tend to have both the pen in one hand and then fingers with the other hand and alternate between the two. So that's the idea of our user interface. And so there's generally two input strategies. One is if you come from especially a desktop, you're going to be mostly in the first case where the mouse and the keyboard is your primary input. Then you have the touchpad as an alternative mouse, and the two-finger scrolling on the touchpad maps to 2D wheel scrolling. All right. So some wheels, by the way, do support 2D scrolling, but most wheels are limited to one. The touch and the pen are optional. And like we just saw earlier, if you don't do anything specific for them, they will just act as a new mouse cursor, right? Then you have the other alternative, and that's when the finger and the pen are your primary input. And there your mouse basically gets converted to a single finger touch. And the wheel of the mouse becomes a two-finger gesture, which means scrolling and panning, right? And you can use keyboard modifiers in that case to switch between scrolling or zooming. You have the touchpad, so that acts. The touchpad is interesting because it does map well to how you would do on the screen. You can either use one finger as if you were dragging things around, and when you do a two-finger gesture, because that maps by the operating system to wheel, two-finger automatically map to pinch, zoom, or pan, scroll around, right? And then you can use your pen as an extra tool or just as another single finger. One caveat, which is, I think, the main thing we saw during our interactions and during our development, the mouse wheel behavior tends to be inconsistent in many apps, and one of them being, for example, Google Maps, which is something we've been talking about Google Maps so long, because the way that Google Maps uses the wheel is it uses it for zooming. But from what we found out in our design sessions, in our experience, in our user experience development, is you should not be using the wheel, the mouse wheel for zooming, unless you know you're going to be heavily only desktop and wheel plus keyboard oriented. You should otherwise use it for scrolling. The problem is that when you use it for scrolling, because most mice only support one directional scrolling, it becomes impossible to scroll sideways. You can only scroll up and down. So there is way to fix this is to require, is to use like the shift key, for example, or to just have users prefer using the touchpad. Sometimes scrolling is implemented as mouse, press, and drag as well. But as soon as you're going to have content interaction, selected objects that you want to move around, that you get into conflicts. Like, is my mouse drag? Should that be a drag on the viewport itself, or should it be on the object? It can become complicated also for developers. Touchpads, on the other hand, have a consistent behavior. The one finger gestures map to the mouse cursor, move, press, release. Two finger gestures map to the mouse wheel, pan for 2D scrolling and pinch down for zooming. So it's consistent on all operating systems, and it also matches what you would do naturally on the touchscreen. The traditional touchscreen gestures are pan with your finger and pinch zoom to pinch to zoom, and just pan and drag to scroll. So our lesson learned and our recommendation based on what we have seen is you should stick to mapping the mouse wheel to scrolling. If you have, I'm guessing, if you only do scrolling, that's not a problem. But let's say if you have to support scrolling and zooming, the mouse wheel should be used for scrolling. You can then, if you have a one-directional mouse, you can use the shift key modifier on your keyboard to switch between horizontal and vertical. And if you want to switch between scrolling and zooming, you use the control key modifier. Again, if that makes sense for your application or not, right? This solution keeps consistency across all touch input types. It works with the mouse. This way you will have one code path for mouse, touchpad, and finger and pen gestures. They will all behave the same way. If for some reason you really have users that really want to have a different behavior for the mouse, it should be specified with an option. This is what we ended up doing with our web client. Some people just do not want to use the touchpad or the touchscreen and really only want to use the mouse. So for them, we have a toggle like scrolling mode where we say mouse specific or just touchpad specific. But from our experience, you can't combine both. There is no way of having one thing that works for everyone. Okay, let me just see. I'm getting close there to the end. Quick check on time again. Francis, am I good? Yes. All right. So I have a few more minutes before the questions. Tips and tricks. So as we saw, pens can make great mice. The only thing to be aware of is sometimes, well, there are OS generated mouse events. If you want to handle the pen events as well as mouse events, there are, right now there is actually, to say what the problem is, right now there's a bug in Qt where Qt does not give you a way to disable the generated pen, the OS generated mouse events once you put your pen on the screen. So I can go back to our example here and I can just show you one way. So this is one way you can do it. If let's say you want to be able to disable mouse events while your pen is close to the front, you can use that trick with an event filter that it's installed either on your app or on your window. And whenever your pen gets close to the window, you just turn a flag on. And when that flag is set, you then filter mouse events. So here's a mouse event handler. We ignore mouse events synthesized by the OS for touch and pen events. So this, by the way, is the equivalent of that QPA flag. That's another way of disabling mouse events from the OS. If you don't want to add the Qtconf flag, you can also do an event filter and disable the mouse, because mouse event synthesized by system is specific to the QPA plugin. No one else in the code does that. So that's how you can use it. The problem is, yeah, there's a bug. It's I have you will have the link for that Jira bug. There is a bug that was introduced, I think, in 5.13, where it used to be able to do this for pens as well, but now it's not done for pen anymore, and because they fixed something else and then the fix was bad. So now you have another regression. So a way to work around it is then you can do this trick. Instead, if it's a non-synthesized mouse event and you know that you have the pen in the proximity of the screen, you can also ignore this mouse event. So that's one way of doing that. I'm going to show you a quick example here of how you can use the pointer type. Like I have my pen here, has little buttons on the side, and one of them is to switch between pen and eraser. And so what I've hooked up here is when I'm in eraser mode, I'm going to convert the strokes into wheel events. So I want the eraser mode to toggle scrolling rather than selecting and dragging things around. Okay. So if I start this thing here, so you see how now without any pen button pressed, I'm just scrolling, selecting objects. Now I'm going to press the little eraser button. Some pens, it's a different tip, but in my case, it's a button. Now with the button being pressed, oh, sorry. I go back here. Why are you failing me? Oh, because the pen disappeared. Of course. Classic. Let me restart. Make sure my scroll. I think my pen just decided to die. Yep. No more pen now. Oh, well, there goes the demo. Well, keep going on because I'm already short on time anyway. That's the Murphy's Law again. I'm going to see if I can screw it while I keep presenting the next tip. Next tip is an advantage of the new QML pointer handlers is they have that margin property. And a common problem with desktop mouse-oriented UXs is a lot of the items, like in menus or toolbars, are often too small for fingers, and so you don't have the precision to tap exactly where you want when they are too close together. So what you can do is, at least on the QML side, is you can specify that margin property to give an extended tap area for the item. So with the items being sufficiently spread apart from each other, or even if they're close to each other, they can have extra margin over them. So even if you're not tapping exactly on the item, you still have the tap will still go through as if you were inside the item. So that's a very nice, and we use that in Bluescape a lot because a lot of our icons are little image-based icons, and we need the area around it to be bigger. So we have some minimum tap sizes as part of our UX guidelines. Custom styles, style sheets. So for the widget world, unfortunately, there's no way you can do that. But what you could do is you can implement a custom style or add a style sheet, which just, adds things like minimum layout spacing, default layout spacing and margin, that sort of stuff. It's not as flexible, but it sometimes that's all you need to make your menu items a little larger and that sort of thing. Finally, a quick word on Qt 6. So things are going to be looking a little different in Qt 6. There's a new QPointer event base class, which, if I'm going to show you here that diagram. So this is our old Q, and of course the pen works again. This is our old Q event, old Q input event. And so there's a new QPointer event here being introduced that now acts as the parent for a single point event, such as mouse event, tablet event, native gesture. And then you also have now the touch event, which contains multiple points. This allows, it doesn't seem like a groundbreaking change, but this allows a lot of cleanup, especially in the way that now QML doesn't have to wrap its own internal event types. And it just makes a lot more sense, because now you can basically query a pointing device for every device. If you have multiple mice, multiple pens, multiple screens, each event now will have a proper, it's not just a unique ID, it's an actual device with access to the hardware specifications and the hardware ID and so on. So on that topic, QTouch device has now been replaced with the generic QPointing device, which is not limited to touch events anymore. So you will get QPointing device for a mouse, for a pen, and so on. And that pointing device, now also works when you have multiple touchscreens together and multiple tablets. You can now properly track each event to each pointing device. So these are good changes. I need to go check again what the latest status is. Maybe one of the Cato guys will be able to pitch in if they know. But also have a couple of patches. We have been through the last couple of years, we've been pushing a couple of patches for the multi-screen support in particular. And I have a couple of pending patches that I could not integrate in Qt 5, which now with this change will be able to go in. So you'll be able to get access to a hardware ID on Windows and on Linux. So you can map IDs across reboots and things like that. That's it. Thank you for following. I want to mention, so I was a fail with my pen, but the demo, I've uploaded the demo source code on GitHub. So if you want to take another look at the demo that I showed, it's up there under /Qt Desktop Days 2020. The slides hopefully will be made available, so I'll give you a second to write this down. And if there are any questions, I think I'm ready to take them. Here we are. Have I experienced many issues with hardware drivers for touch controllers from Teal? For the most part, we don't test. We've tested. We have two different hardware technologies that we support at Bluescape. The one we're using most commonly now is a FlatFrog based monitors. They are it's a type of touch technology that fits for large screens and like think of desktop and up. And they integrate the pen and finger recognition. For the most part, it works. We have a Linux Ubuntu, and they work out of the box. And on Windows as well, they're integrated perfectly with Windows OS. On Windows, we just it's the OS that does the touch for us, and that gives us the touch. So we don't have a lot of issues. One thing that's causing us grief on Windows, though, is when we are in multi-monitor setups. We are using NVIDIA. Well, we're using scaling like NVIDIA Mosaic, or Intel has its own way of scaling your desktop across monitors. And the one gotcha on Windows is Windows does the scaling of the graphics, but it doesn't, of the desktops, I should say, but it does not do the scaling of the touchscreens. So while you have your desktop nicely mapped on 4 monitors, you only have, like, if you touch each monitor, you get the 0 to 100 on each monitor. So for that, we have had to add our own translation layer. And that's why we needed to have access to the hardware IDs for each touchscreen that are persistent across reboots. So yeah, that's been the main issue. But on Linux, we've never really had like with Ubuntu, we use a desktop class Ubuntu OS, and we haven't had any issues there.
So how about you could maybe answer the one from John. What is the best way to represent digital ink in Qt applications? Should each ink stroke be a Q-Quick item, or is QML not suited for this?
It depends on what you're going to do. So I guess a good example, as I was doing those little strokes on my presentation, you guys could see, right, when I was stroking on my slides and doing annotations. If it's that sort of stroke, something very small and simple, using a QML shape, having basically a recognizer for the whole window and creating little shapes as an answer to that is good enough. But if you want to start having more complex things like shapes that convert into, like auto recognition into proper shape objects or selectable strokes, the way we have, we do it on the C++ side on our system on Bluescape, simply because of strokes. We want to manage, the smoothing and stuff. There is some post-processing, as good as the pens send you data. There is some post-processing needed, we found. So we do that on the C++ side. And from a frame rate perspective and also latency perspective, I'm not sure, depending on the size of the QML application. It really depends on, what hardware you have, what is the size of your application. I would say for small cases, doing it in QML with small object is fine. But for a larger, when the pen inking is as a core part of your application, you're going to want to do it, to have a proper module dedicated on the C++ side. Just for the same reason, I wouldn't do multi-touch in QML unless it's very simple. Like I was saying, I prefer to still have my own manager on the native side. Yeah.
Okay, so we have another question which you might have answered already. I'm not sure. In your presentation, is from Ivan Tarozzi. Is pressure level supported for pen?
Yes. Again, depends on the technology, but the active pens, like the Wacom style pens that the Surface Book has, for example, or the Surface line, they do support 1,000 levels of pressure. We're not actively using that in our app, but we'll have prototypes where we're making use of it to change the width of the shape, the width of the stroke. Yeah.
Okay. So then another one from Stan Morris. I have a non-touch monitor and I want to develop a gesture-enabled app. Can you recommend a touchpad for use for the desktop? For example, an old Wacom tablet, Bamboo, with multi-touch. Pinch is interpreted as scroll. Not what I need.
So I would not be able to answer that. I have not used the Bamboo tablet directly, so I would not know what they mean by multi-touch. Sorry about that.
Okay. So then finally, I think this is the last one, but maybe not. From Sergio, is all this stuff unit tested in Qt? I can imagine it's hard to test without proper hardware setup.
That's a good question. There certainly are some unit tests, and as part of their also input event handling, they are testing that the flow it works, but the general input event flow, yes. But of course, they do not have automated test for exactly when you need specifically hardware, things like on Windows, when Windows will send you, and even as of the regression I was talking about, maybe that's what it was referring to. Yes, it's something I'm guessing. The way it worked is there was Jira tickets where someone was like, oh, my Wacom tablet doesn't work in Qt Quick anymore after 5.13. And the guy was like, oh, I know what it is. Let me go make that patch in one of the Windows platform files. And they changed that. And by doing that, now they broke the pen case because I'm guessing there was no unit test for that specific hardware OS situation. So some of it is unit tested, but it's not 100% coverage, of course, especially not when it involves the actual hardware. But overall, I have to say, to give some credit, having worked with them over the past 3 years, I have to say it used to be way worse. When we really started Windows 3 years ago, it was they did not have yet even before Windows 10, they did not have, you had to use a special, I forgot what the name was, for like the tablet support, and it was way buggier than it is now. Now at least they've cleaned up the whole pointer handling. So there were a few kinks to work out with, but I was working with Andre De La Rocha, if you guys are familiar with him. And generally, it's been pretty easy. They've integrated some of our patches pretty well, and so it's that's why I'm kind of I feel like it's probably not the worst area in Qt, as let me put it this way. It's got some kinks, but it's not completely, it's still fairly okay.
So I think we're just about going a bit over time, but I think there may be one other question that you didn't answer, but you can tell me if you did. Is Qt's touch support 100% cross-platform, Mac, Windows, Linux, or are there some traps we should be aware of?
The one trap is Mac, because of course Mac does not officially have touchscreen support. It does have the pen support, but we're not officially supporting Mac at this point. We are working on it, but not yet. So it's a little early for me to tell you. I know that they are a couple of paths specific to Mac when it comes to the touchpad. But yeah, so pen and touchpad at least should be, are across the desktop platforms is pretty well cross-client. But the big question is, testing a touchscreen on Mac. I vaguely remember we tried to plug one of our USB touchscreens, but Mac didn't even recognize it, as it would not even give us anything from it. So that's the one question that remains. Yeah, everything else we know is fine, but touch on Mac is not a problem.
Well,
not working.
That's great, Romain. Thank you very much. I think we'll stop there, and I thank you again, and thank everybody for attending, and stay safe all. Thank you.